Hello friends, my name is Utsav Gupta and today we are going to learn about lasers. Laser is the acronym of light amplification by stimulated emission of radiation. It is a device that transforms light of various frequencies into a chromatic radiation in the visible, infrared and ultraviolet regions with all the waves in phase capable of mobilizing immense heat and power when focused at close range. The invention of the laser. Laser was invented in 1958 by Charles Townes and Arthur Schawlow of Bell Laboratories. It was based on the Einstein's idea of particle-wave duality of light, more than 30 years earlier. Originally called maser, where M stands for microwaves. Now the characteristics of laser. Laser having four characteristics: coherence, high intensity, high directionality, high monochromaticity. Coherence. The wave trains which are identical in phase and direction are called coherent waves. High intensity. Due to the coherent nature of laser, it has the ability to focus over a small area of 10 nanometer. High directionality. The angular spread of a laser beam 1 millimeter per meter. High monochromaticity. The light from a normal monochromaticity source is spread over a range of wavelength of the order 100 nanometer, but the spread is of the order 1 nanometer for laser. Stimulated and spontaneous emissions. Stimulated emission. It is not a random process. The photon gets multiplied through chain reaction. It is a controllable process, more intense, monochromatic radiations. Spontaneous process. It is a random process. The photon do not get multiplied through chain reaction. It is not a controllable process, less intense polychromatic radiation. Types of laser. Laser are of three types: by active media, by mode of operation, by pumping and laser levels. So in active media we have three types of laser: solid state laser like ruby laser, titanium sapphire laser, semiconductor laser; gas laser, helium neon laser, argon laser, CO2 laser, nitrogen laser, SCN laser; dye laser, dye molecules in liquid solvent, sometimes in solid also. By mode of operation there are two: CW and pulsed. By pumping and laser levels there are two: 3-level laser and 4-level laser. Solid state laser general properties. Solid state laser use high density solid media as active laser materials. Ions of transition element particularly are rare earth elements or transition metals are used most commonly as dopants. Host materials include crystals like sapphire, YLF, YAG, LeCef, LeCaf, as well as glass from silicate and phosphate classes. This is the diagram of ND-YAG laser. Energy level diagram of ND-YAG laser. Advantages. No chance is of wasting material in the active medium because here material used is in solid form, not in gas form where this occurs. Both continuous and pulsed output is possible from solid state laser. Solid state lasers have high intensity. Construction is comparatively simple. Output power ranging from very low value of about 0.04 watts to high value of 600 watts. Cost of solid state laser is economical. Disadvantages. Efficiency of solid state laser is very low as compared to CO2 lasers. Great disadvantage of solid state laser is the divergence, which is not constant and ranges between 1 milliradian to 20 milliradian. Output power is also not very high as in CO2 lasers. Due to thermal lasing in solid state laser, the power loss occurs when the rod gets too hot. Application and uses of solid state laser. Nd:YAG solid state lasers usually used when drilling holes in metals. Nd:YAG pulse type solid state laser used can be in medical applications such as in endoscopy. As military application, Nd:YAG is used by target destination system. Ruby laser. Ruby laser is the first laser demonstrated by Ted Mem. Host material is corundum crystal. Dopants are chromium ions. Lasing wavelength is 694 nanometer. Pumping is done with flash lamps and laser operates in pulsed regime. Construction and working of ruby laser. This is the diagram of the ruby laser. This is the energy level diagram of ruby laser. Advantages of ruby laser. From cost point of view, the ruby lasers are economical. Beam diameter of the ruby laser is comparatively less than CO2 gas lasers. Output power of ruby laser is not as less as in helium neon gas lasers. Since the ruby is in solid form, therefore there is no chance of wasting material of active medium. Now, the disadvantage of ruby laser. In ruby lasers, no significant stimulated emission occurs until at least half of the ground state electrons have been excited to the metastable state. Efficiency of ruby laser is comparatively low. Optical cavity of ruby laser is short as compared to other laser, which may be considered as a disadvantage. Applications of ruby laser. One of the first applications for the ruby laser was in range finding. Due to low output power, they are class 1 lasers, so may used as toys for children. It can be used as decoration piece and artistic display. So that's all for lasers. Thanks.